Hey guys, today we're going to start a new unit going over polygons and quadrilaterals. So we're going to start by talking about the angle sum. At the top of your notes, you'll see interior. So interior means that this is the angles inside of your polygon. So the formula that goes with this, or actually let's write the theorem. The sum of the interior angles of a polygon is n minus 2, that's in parentheses, times 180. N stands for the number of sides that the polygon has. Okay, so we're going to do a few examples using that formula. So we're just going to follow this formula every single time. Okay, for example 1, it comes in 3 parts. All they want us to do is find out what that sum would be. So the first shape that they give us is a nonagon. So I'm not sure if everybody knows the vocabulary, but a nonagon is just a shape that has 9 sides. So in this case, n would be 9. So if I plug that into our formula from earlier, we would have 9 minus 2 times 180. So just put that into the calculator all at once, and we get 1,260. So a shape that has 9 sides would have an interior angle sum of 1260. Okay, the next one is a dodecagon. So same thing, I'm not sure if we know the vocabulary, but dodeca means that this is a shape that has 12 sides. So n would be 12. So using that same formula, 12 minus 2, then times 180, put that into the calculator, and we get 1,800. So a shape with 12 sides has an interior angle sum of 1,800. Okay, but these vocabulary words, it only really goes up to 12 sides. Once you have 13 or more, there are no more names. So this one that says 23gon just means that it's a shape that has 23 sides. Okay, so formula again, 23 minus 2, then times 180. That gives us 3,780. So a shape with 23 sides has an interior angle sum of 3,780. Okay, so the next example, example 2, has us work backwards from there. So given the total amount of degrees inside of a polygon, can we say how many sides that polygon has? So it's the same exact formula as from over here, n minus 2 times 180, but we're going to set it equal to whatever number they gave us. So for that first one, we're going to say n minus 2 times 180 is equal to 1440. So this takes 2 steps to solve. Since the n minus 2 is being multiplied by 180, we're going to divide both sides by 180 to cancel that out, which now gives us n minus 2 is equal to 8. Then we would add 2 to both sides, and we get that n equals 10. So this shape that has a total of 1,440 degrees is a shape that has 10 sides. So just for the vocabulary, we call this a decagon. Okay, the next one, so 2,700. So same formula, n minus 2 times 180 is equal to 2,700. We're going to work this out like we did before. So let's divide both sides by 180. that gives me that n minus 2 is equal to 15. Then let's add 2 to both sides. So n equals 17. So there is no name for this kind of shape. We would just call this a 17gon. Okay, and then the last one there, big number, 8,000. So this means that it's going to have a lot of sides. N minus 2 times 180 is equal to 8,820. Let's divide both sides by the 180. So n minus 2 is equal to 49. Then add 2 to both sides. So n equals 51, making this a 51gon. Okay, so all of this was just dealing with the inside of the polygon, interior angles. So what about the angles that are on the outside? So in this case, we would call these exterior angles. So this one I think is actually simpler than before. Let's write down the theorem that goes with this. The sum of the exterior angles of a polygon is, so it turns out that this time we don't even have a formula. It's just straight up 360. Doesn't matter what kind of shape it is, the outside angles are always going to be equal to 360 degrees. So when I say outside angles, all that means is, so I'm going to draw just a random shape. So all the angles are normally inside. So we're used to seeing these in here. But to make them be outside angles, you extend the line, and now this angle is on the outside. So that's what we're talking about when we're talking about exterior angles. And that goes all the way around the shape. If you extend all the sides, you would have exterior angles in all 4 corners. Okay, so let's look at our examples. What they're going to have us do is solve for x. This one here has 4 exterior angles. And I know that their sum needs to be 360. So let's add all of these up. 93 plus 75 plus 2x plus x needs to equal 360. I'm going to combine like terms, so these first 2 can go together. That's 168. And then these 2 both have x's, so those can go together. Now let's subtract 168 from both sides. So now I have 3x equals 192. Last, I would divide by 3. So x is equal to 64. Now that I know that x equals 64, it didn't really ask us to do this, but I'm going to do it anyway. This missing side over here that was just labeled as x, I know that that angle is 64 degrees. And then this one over here that was 2x, I would just plug in the 64. So 2 times 64 is 128. So that's just extra information. That does come up on the homework though. Okay, so let's look at another one. Here's my new shape. So make sure that these are all exterior angles, so they're all on the outside. So we're going to add up all of those values and make it equal 360. So 3x plus 7x plus 6x plus 100 plus 20 equals 360. So all the ones that have x's, I'm going to put them together. So that's 16x. And then these over here that are just constants, let's combine those. So I get 16x plus 120 is equal to 360. Subtract the 120. So 16x is equal to 240. And then divide by 16, which gives us x is equal to 15. And same as before, now that I know that this is 15, I can find the value of those missing angles. So 3 times 15 is 45. This is 105. And then this one is 90, meaning that's a right angle. Okay, we have 2 more examples. Part C. So we're adding up all of the outside angles. So I have 60, 4x, x, 2x. But this one right here doesn't have a number. So you just have to remember that that little square means 90 degrees. And then just the same as the other ones. 90 plus 60 plus 4x plus x plus 2x. So all of them equals 360. I'm going to combine these first two because they're both constants. And then the next 3 are all x's. So that's 7x. Okay, subtract 150 from both sides. So 7x equals 210. Divide by 7. X equals 30. So now that I have that, I can fill in the missing sides. 2 times 30 is 60 degrees, then 30, then 120. And last example. Those are my 4 outside angles, exterior angles. This time, none of them are constants. They all have x. So we need to find x first by adding these all together. And making it equal 360. So since they all have x, they are all like terms. So combining that gives me 72x equals 360. So this one's just one more step. If I divide both sides by 72, I get x equals 5. So now that we know that equals 5, I'm going to go around and find all the missing sides. So 8 times 5 is 40. This would be 50, 120, and 150. Okay, so all of this goes with exterior angles, which the main rule is that it needs to equal 360 degrees. Doesn't matter what kind of shape it is. Okay, and that is it for today.